My name is Scott Perello. I'm the COO and a partner with the Building Envelope Group. Thanks for joining me today. Today we're going to discuss joint sealant replacement basics. More specifically, just an entry-level overview of the types of joint sealants we commonly see in the commercial building envelope world and a basic rundown of the installation process of removing and replacing joint sealants, whether it be locally or a global replacement process. So let's dive in. So there are two basic uses of joint sealants that you'll find in commercial facades: weatherproofing sealants and structural sealants. What we're mostly going to encounter are weatherproofing sealants. The most common use for exterior joint sealants is to prevent water and air from penetrating the facade at the numerous joints, penetrations, and interfaces between different materials, and at perimeters of doors, windows, louvers, and so forth. Furthermore, weatherproofing sealants allow for movement within and in between materials due to thermal and volumetric expansion and contraction. Structural sealants primarily are used to adhere glazing panels, glass, structurally to each other in glass metal curtain wall systems. There are other uses, but these sealants also provide weatherproofing and movement capabilities. Just a cautionary note: never remove and replace glass-to-glass joint sealants until it is confirmed whether or not the panels are adhered within the structural sealants. Sometimes they're adhered, with structural sealants in a combination of metal clips and anchors. Sometimes only the structural sealants are holding them together. And it can be a very dangerous situation because some of these glazing panels are extremely heavy if you cut them out and they're not held into the system some other way. So the basic types of weatherproofing joint sealants found in commercial facades. There are many different types of sealants that you can encounter: acrylics, latex, butyl, polysulfides. But the three most common we're going to encounter are polyurethanes, or otherwise known as urethane, silicones, and hybrid, silane modified polymers, but we call them hybrids for short. So to break it down a little further, urethanes. So it's the typical sealant used for decades in most applications. I've personally been using, polyurethane since the 1980s. The benefits include low cost, great movement and adhesion to most substrates. They're compatible with most substrates. They're paintable, which is great in certain situations. They're easy to install. Limitations: they may stain some porous substrates. They're an organic material, so they're subject to UV breakdown, reversion it's called, and they have a limited lifespan. Regarding reversion, basically that's the process of any organic material chemically breaking down through the UV rays of the sun, trying to revert back to their original chemical state. Rust on a piece of steel is basically reversion, the same thing. Anyway, manufacturers' warranties are typically 5 years for urethanes. So silicones, they're originally designed in the structural application world, but over time, the last few decades, they've become really popular as a weatherproof sealant. Benefits are they're inorganic, so they're very high UV resistance, almost negligible. The building components can crumble around them, and yet the silicone materials typically will have the same cohesive properties because they don't really break down the way organic materials do. They have excellent movement and adhesion characteristics to most substrates. Manufacturers' warranties are typically 20 years. Regarding application in low temperatures, although, temperatures below the 40s, which is pretty typical in urethanes and other waterproofing materials, that's usually we want to install 40 degrees and rising. Silicone material itself is not really concerned with temperatures below 40s or even freezing for that matter. But a word of caution, I do not recommend installing joint sealants, even silicones, below freezing, because what can happen is moisture, water molecules in the substrate can freeze and inhibit bonds during thawing. So very, very, but in the higher 30s and whatnot, you can in most cases safely install silicones. Limitations: they're higher cost. They can stain porous substrates similar to urethanes. They're susceptible to dust adhering to the surface after, for instance, silicone elastomeric wall coatings What's great about silicones is that they got a very high perm rating, very high permeability, moisture vapor, runs right through that versus some other elastomeric coatings. But one of the negative impacts is that they do collect dust over time. So if you use silicones, having a regular cleaning, pressure washing or power washing, facade protocol, it's a good way to keep up on that. Silicones are a good product. And then hybrids, which I personally have grown to like hybrids for a lot of different reasons over the years. But basically, over the last couple of decades, they've become a great alternative to urethanes. They're similar to urethanes, with the similar advantages like low cost, but they got a much higher ultraviolet ray resistance because they have silicone molecules in them. So it gives them a much more extended lifespan, yet for a very similar cost to the urethanes. Other advantages are some hybrids, they can adhere to wet substrates. I was involved in the development of a system, which is a silo-terminated polyether, liquid applied flashing and sealant system that actually wants wet substrates. The moisture incorporates itself into the adhesion process. So that's a great benefit. If you're doing, you need to get an emergency sealant in, that's a great product to use. Just make sure that, the particular chemical, formulation for that hybrid will allow, adhesion on wet substrates. And then typically the warranties are 10 years for a lot of these hybrid sealants. So, for pretty much the cost of urethane, you can install hybrids and get twice the manufacturer's warranty without all the complications that can come from going from urethanes to silicones if you're going to do a full replacement. And I'll touch a little bit on that later. All right, so the physical removal and replacement of joint sealants. This is a rundown of the actual process, in the field. And of course, coupling this presentation with, in-field training, hands-on training is critical for, developing, a joint sealant mechanic skill set. So the first thing you do is completely remove all the existing sealant. We're not going over the existing, skimming over it. We're not doing anything like that. We're completely removing the existing sealant. That's going to have new sealant installed. But no, if replacing sealant with a new type, such as going from urethane to silicone, like I had mentioned, additional measures such as grinding the surface completely may be required. What happens sometimes if you're going from one type to another type, the residue can be left behind and have it become a massive problem for adhesion. You should remove, regardless of what you're replacing with, remove as much material as possible. Pre-construction testing will show what level of prep you need to do if you're doing a full system replacement. Always perform pre-construction testing prior to a full system replacement. And typically what I do is I'll do a few mock-ups. I'll do some with, hand tools only. I'll do some with hand tools and power grinders and things along that order, and just to see what level of prep is required to, pass proper installation. You want to clean and wipe the joint shoulders, excuse me, with the appropriate solvent. Make sure you understand the manufacturer's requirements. Certain alcohols, certain solvents work in certain situations and not in others. So be sure you understand that and how they flash off and how you wipe them. Read the manufacturer's instructions on that. So you install primer if required. Allow primer to set, typically 15 minutes. Install the appropriate bicellular. Typically, that's what I like to use. It's called soft rod. Compressed backer rod. There's different types of backer rod. Typically, you have your open cell, you have your closed cell, and then you have your bicellular, which has become more popular in the industry. Open cell, the real soft, squishy type, it can tend to be a moisture wick. So a lot of folks kind of shy away from that. And then the closed cell backer rod, it's very stiff. And it's at times difficult to install because of gassing that happens if they're not completely continuous, and variations in the joint widths become problematic. So I typically recommend the bicellular. It's almost the standard today. Prepare the caulking gun and nozzle for appropriate joint width and application, which is a 2-to-1 depth ratio. So the depth of the sealant at the middle of the joint is half of the width. I'll touch on that in a minute. Going back to primer, there are some in the industry that say you always want to prime the joint. And what the primer is, it's just basically a liquid, low viscosity liquid that you brush onto the joint shoulders. You wait, for it to tack up in about 15 minutes. And then it's supposed to promote bonding, in which it does in certain situations. But there are situations where, the primer itself now becomes another layer that can be maybe bonded to the primer. And then maybe at times later on, the primer loses its effectiveness and actually loses bond to the substrate. So going back to where, we said in all cases, if you're going to do a full system replacement, I strongly recommend mock-ups prior to construction, including the various preps to do, as well as the different primers. One with primer, one without primer. Put them all in different, prep methods, let them all cure out. And then once it's ready, do performance testing, pull testing. And if they pass the pull testing without primer, then proceed without primer. That's my recommendation. And the industry, for the most part, concurs with that. Note, if the total depth of the joint sealant does not allow for installation of backer rod, which I'll touch on in the next slide, in order to prevent three-sided adhesion, where basically the sealant is not just glued at the sides of the joint, but underneath, that's not good, because what it'll do is instead of just going this way back and forth, it will be pulling the shear. It'll be glued in the back as well as the shoulders. That won't allow free movement. So you want to make sure that the sealant is not adhered to the bottom of the joint or the back of the joint. So that's where bond breaker tape comes in. Assuming you have the right depth, you put bond breaker tape in to whatever material, such as mortar, is behind that joint, and then that'll allow free movement of the joint as designed. Install the joint sealant by slowly pushing the material into the joint, completely filling without air pockets. So you don't pull the sealant in quickly. You slowly let the material enter the joint and fill up, and slowly move across by pushing it so that there's no air pockets behind it. And then using the appropriate size shaped spatula or slicker tool, there's a couple of different techniques, field techniques, but the most common is you overfill the joint just a little bit, and then you back tool it with the slicker or spatula to help shape it, and then you compress it with the same spatula, which does two things. One, it shapes the sealant so it looks aesthetically pleasing, but even more importantly, it's compressing the sealant into the joint, into the shoulders of the joint, forming it so that it's a mechanical bond into the porous nature of the substrate. So you have your chemical bond, you have your mechanical bond, which is important. Pretty much a lot of waterproofing. And then of course you have your 2-to-1 ratio. So in other words, if it's a 3/4 inch wide joint, at the center it would be 3/8 of an inch, obviously half. And that's just a quick profile of what it looks like. And the hourglass shape is important when possible. When possible, have that's the bond backer rod. You typically install backer rod so it's tight in there. So when you squeeze the material in, it's working as a backstop, a form, if you will, for the sealant until it cures, as well as when it is cured, it allows to continue that shape. Full adhesion on either side, half the distance. So once again, if this is 3/4, that would be 3/8 in the middle. Just a couple of quick photos of the different types of prep. As I said before, you may have to grind out the joints. If pre-construction testing on a full system replacement shows that hand tools and scraping and wiping is all that's needed to pass a pull test, and you don't need to grind, especially if you're going back with similar material, compatible materials, then I recommend doing that for a number of reasons. Cost, noise. There's a lot of reasons why. If you don't have to do all the extra grinding, don't. But once again, there are different ways to cut it out. You have, powered caulking cutters there. You can see that they have them pneumatic, they have them electric, as well as just, knife cutters, just hand tools. You can see the installation of backer rod. Once again, you can see they're installing the sealant by pushing it in there, filling it up completely. And that's just an example of a spatula, in a finished product on a joint. Recently, one of our BEG partners, we did some training. I was at their headquarters doing training in water testing, doing training in joint sealant installation, and other things. There's just a few pictures from that training. I was very impressed with the way that their team picked it up and was focused on. A number of these folks will be part of their rapid response team, responding to leaks and trying to do water testing and assess issues, as well as doing temporary and permanent joint sealant installations. You can just see, where they're installing, they're doing cutout, following the thing. And this is more of a wet glazing application. This is a perimeter joint sealant, brick to metal installation. You can see how they're filling it up, how they're tooling it, back tooling it, wiping the excess off on another spatula, installing installing the back rod. And then finally, and after, one long day working with me in the field, I was very impressed, with their team. I mean, brick to brick is more, probably the most difficult to caulk and have a good job because of the joint, goes in every brick, and it's hard to keep that looking really consistent and straight. And I was very happy when I left. And, and as a BEG partner, my goal was to down there to train the trainers. And before I left, I saw their lead folks training other people on the same installations that I was teaching them. So that was fantastic. And that's really the goal of the BEG partnership program. So really, that's it. This is just a brief little overview of joint sealant installations. As always, if you have any questions, hit me up. My phone number's there, my email. Feel free to call, say hello. And any questions you have, I will respond to your email as soon as possible. Thanks, and have a great day.